I'm Anil Kumar, and now we'll discuss few applications of dot products from test papers. This is part 2 of our review on dot products. We'll do questions like shown here. We'll try to understand what is scalar and vector projections of dot products. Based on this, we'll have a question which you can pause the video, copy from here. And based on this, we'll have a bonus question to find area of a scalene triangle given points A, B, and C. Well, these points are similar to what we took in previous two examples. And then we'll have an application question on work done, followed by simple multiple choice question to wrap it up. So that is all which we are going to cover in part 2. You can actually pause the video, copy these questions, solve them, and then look into my suggestions. So now let us begin with projection of vectors. Here is an example. We'll try to understand what exactly scalar and vector projections are. So the question here is, describe when each of the following is true. So A is projection of vector A on B equals to projection of B on A. So when we say projection of, we are trying to say vector projection. So this is regarding vector projection. Now the second one, part B, is, so you see the absolute value, that means we are talking about scalar projection. So we can say scalar projection of A on B is equal to scalar projection of B on A. Now basic difference between scalar and vector projection is of direction only, correct? Otherwise it is all same. So let's consider them one by one. So let me say vector projection. And scalar projection. So let's talk about scalar projection first, and then we'll add direction to make it vector projection, right? So let's say these are the two vectors given to us. One vector, the other one kind of like this. So when we are saying projection, we're talking about scalar first, so I'll consider this one. Projection of A on B. So let's say this is A and that is vector B. Projection of A on B basically means like this. Just drop a perpendicular here. So you can say there's a sun here, the shadow falls here, and that is the projection. This much, right? Without direction. So we just say this length is the projection of A on B, right? So if the angle is theta, you can see that scalar projection is A cos theta, magnitude of A cos theta. So that is projection of A on B, right? And this gives you absolute value, makes it scalar projection. On the other hand, if I am looking for projection of B on A, so B is this vector B, right? So on A, let me extend this a bit. So that perpendicular gives you this length. So this length becomes projection of B. If I say this point is O, then this is B dash. Let's say this is B. Then OB dash is the projection, which is equal to magnitude of B and the same angle cosine theta. Do you see that? Or this is what we are saying, projection of B on A. That's another nomenclature. Now if you want to make them equal, what should be same? Well, cos theta is same. So basically you say that this is true, that is part B is true, if magnitude of A is equal to magnitude of B. Perfect? Correct? Now, if the magnitudes are not equal, even then we can have the same projection, provided theta is 90 degrees. Then both are 0, right? So we have 0 equals to 0. So these are two conditions. So we have two conditions here. Magnitude of A equals to magnitude of B, or the angle theta is 90 degrees. That is to say, if I have a vector like this, then their projection on one another is going to be 0, right? Shadow will be at noon position. Do you see that? Okay. Now let's get back to the vector projections, right? So we'll take the same vectors. Let's say this is one. The other one is correct. Now when I say projection of A on B, it really means this much with the direction. And this direction is along the direction of B, right? If I have to write vector projection of B on A, then it will be, so that is the end point of B. I'll drop a perpendicular here, and this becomes the vector projection of B on A. Now the question is, we are looking into part A now. Where are these two equal? So as we reasoned out earlier, if A and B are perpendicular, that is if theta, the angle theta between them is equal to 90 degrees, in that case they'll be equal, correct? That's one thing. Second, very important thing here is the direction. So if A and B are coincident. Coincident means they are in the same direction. That is to say, both A and B are in the same direction. In that case, vector projection of one on the other will be same, right? So when A and B are coincident, that means in the same direction. Correct? So these are the two conditions when the vector projection of two vectors are going to be equal. So I hope the concept is absolutely clear. Now let's take up an example of calculating scalar and vector projection. We are given vectors OA 2, -3 and OB 1, 4. These are position vectors. Three questions based on these vectors are: find vector projection OV of OA on OB, illustrate projection geometrically, find the vector AV. Okay, let's do one thing. Let's kind of sketch the scenario. Now when I say vector OA is 2, -3, so it could be 1, 2 and -3, 1, 2, 3. So that is my vector OA, okay, so approximately here. So I'm saying O, and this is A, which is 2, -3. So that's the position vector OA. For OB, it is 1, 4, so 1, and say 1, 2, 3, 4, somewhere there, right? So let's say from here, so we'll call this as B, 1, 4. Now, find vector projection OV. That means V is a point on this line, projection of OA on this. So to get this projection, we'll extend, correct? And the projection will be at right angles. So kind of, let's say like this, at right angles. So the projection is this much. Do you see that? That is the vector projection. And this point here will be called V. So I hope the situation is very clear, right? Illustrate projection geometrically. OV is the vector projection of vector OA on OB. Now we need to find OV. That is what we need to find, correct? So let's do it. We'll use the formula straight, right? So as you know, vector projection, let me write down, of, let's call this vector as B and this as A, just for simplicity, right? So when I say vector projection of A on B. This is another convention used in many books. Then vector projection is the dot product of A and B, right? So we are doing A on B. So it is dot product A and B divided by, we want to find direction within B, right? So this times the vector B. So that becomes the formula for vector projection, correct? Now, it is given to us, okay, let's do it here. So A dot B, so we have 2 minus 3 dot 1, 4, okay, over B dot B, which is 1, 4 dot 1, 4. That gives you the magnitude square, right? And this is 1, 4. Is it okay? Now we can calculate. So it becomes 2 times 1 as 2, minus 3 times 4 is minus 12. I mean minus 12. And divided by 1 plus 16. And the vector direction is this, which is equal to, this is minus 10 over 17, 1, 4. So that becomes the vector position of A on B. So coordinates of point V, or you can say OV, which is a position vector, could be written as minus 10 over 17 minus 40 over 70. Do you see that? So that is the vector projection of A on V, correct? So we have done these two parts, illustrated and then found OV. Now question number 3 is find vector AV. So now we have to find the vector AV. Now this is very important. How do you find AV? Now A to V means that it is OV minus OA, correct? That is AV, right? So AV will be written as OV minus OA. So O to V is given here, which is minus 10 over 17, minus 40 over 17. Take away OA, which is 2, 3. 2 minus 3. Correct? So that is what AV is. Now, finding AV is actually useful at times since, do you see one thing? Let me show you here very clearly. It's an application. If I join B to A, we have a triangle and we can find the area of triangle as half base times height. So AV is the height of this triangle, correct? So let's solve this. So we have this minus this. That means minus 10 over 17 minus 2. And the y coordinate is minus 40 over 7 plus 3. Or that is 34. So we can write this as minus 10 minus 34 over 17. And this is 17. 51, right? So minus 40 plus 51 over 17, which could be written as minus 44 over 17, and that is 11 over 17. Do you see that? So this is AV, correct? So we can find AV using that particular method. Now the question for you here is, let me add a question here. We'll call it question 4. Find area of triangle OAB. Find area of triangle OAB. I've already given you vector AV, correct? So that's a very interesting question. Try it out. It is sometimes a challenge question to attempt. Okay, so let's move on to the next question, which is what I was talking about. So here we have a bonus question. The bonus question for us is regarding area of scalene triangle with dot product. We have to find area of a triangle formed by the vertices A, B and C, and as you note, these are exactly same vertices which we took in our example, right? So they're exactly same vertices. I've done it on purpose. So B is 1, 4, let's say this is B for us, and A is 2 minus 3, let's say this is 2 minus 3, and this is 0, and the triangle formed is kind of like this. We have to find area of this triangle. How will you find it? Well, one method is what we did in the last part of this video. That is, you could find this side, correct? Let me name that just as we did last time. We'll call it V. You know what AV is. Magnitude of AV times half OB will give you, because that's the altitude, right? The area of the triangle. Perfect. So that's how you could find it. But here we'll talk about alternate method. Okay, which is actually a better method to find area of any scalene triangle. So yes, the idea is that area of the triangle will be half of the base. So the base is OB, right? So OB times the height, which is AV, right? So the magnitude of these two will give us the area. Now, how do we get AV? Well, since we know the position vectors OA and OB, we could actually use A dot B. Let's say this is, or we say OA dot OB is magnitude of OA times magnitude of OB perfect times cos of theta, where angle theta is between them. So OA dot OB is 2 minus 3 dot 1, 4, and this is magnitude of OA is square 2 square plus minus 3 square times 1 square plus 4 square times cos of theta. Now this is 2 minus 12, just as we did last time. And we'll divide by these magnitudes, which is 4 plus 9, 13, right? And 1 plus 16, 17. And that is equals to cos theta, which clearly is minus 10 over square root 13 times square root 17. Now, from here we can find what angle theta is, right? Just find what theta is. So theta is, we'll do cos inverse. Within this we'll do minus 10 divided by square root of 13 times 17. 13 times 17, bracket close, equal to. That gives you 132. So this gives you theta is equals to 132.27. We can write this, yeah, okay, 0.27. Now, from here we can find the angle phi. So phi is equals to 180 degrees minus 132.27 degrees, which is, let's do it. So we'll take away from here 180, right? And we'll use positive sign, 47.72. 47.72 degrees, correct? So angle phi is 47.72 degrees. Now we can also write area of the triangle as half, base is OB, which is magnitude, and AV is actually magnitude of AV sine phi. Do you see that? Sine phi. So that gives you the area. So we know half, magnitude of OB is, we know OB and OA, we have got 17 and 13, so square root of 17, square root of 13, and sine of 47.72 degrees. That gives you the area, right? So let's do this calculation. So we have, let's say, square root of 17 times 13, and we'll divide this by 2, and then we'll multiply this by sine of 47.72 equal to. So we get 5.499, which is equal to 5.5 units square. Do you see that? So we can find area using this alternate method. So using dot product, find the angle between the vectors, and the exterior angle will be 180 minus that angle. Use sine of theta to get your answer, right? Okay, so let's move on to the next question, and I hope you find this strategy, the alternate method, also useful. We are almost at the end of our application questions. The question here is, Anil jumps out of an airplane 4 kilometers above the Great Pyramid of Giza and parachutes down to its point. If the work done by gravity on Anil is 3 million Newton meter, find mass of Anil and his equipment. So we are given the work done in this particular case. Work done is 3 million Newton meters or joules, and the distance is given to us as 4 kilometers, which could be written as 4,000 meters, right? The units are for distance in meters. We need to find the mass of Anil and equipment. We need to find mass in this particular case. Now, work done, distance, and force are related. We know work done is a scalar quantity, which is dot product of force and distance, right? Basically written as magnitudes of force times magnitudes of distance times cos of angle between them. Now let me rewrite this formula as normally we do. We write down work done as force dot d, right? Which is magnitude of force times magnitude of distance times cosine of angle theta. Now since position of Anil is directly above the pyramid, theta for us is equal to 0. So let's substitute these values. For work done, it is 3 million, so 3 and 3 zeros equals to force we need to find, distance is 4,000, cos of 0 degrees, right, which is 1. So we can write down that force is equals to 3 million divided by 4,000. Cos 0 is 1, so this is equal to, let's calculate. So 3, 1, 2, 3, 1, 2, 3 divided by 4, 1, 2, 3 zeros, 750. So you get force of 750 newtons, correct? So you have divided basically Newton meter by meters to get newtons. So that is the magnitude of force, correct? Now to find the mass, we know another relation which relates force with acceleration due to gravity and mass. So force is mass times acceleration due to gravity. The value of g is 9.8 meters per second square, right? So from here we can find mass of Anil and equipment as ratio of force to gravity, and in this particular case it will be 750 divided by 9.8 to give us mass in kilograms. So we get 750 divided by 9.8, which is in decimals 7.76.5 kilograms, right? So we're working in MKS units. So we get our answer as 76.5 kg is mass of Anil and his equipment, right? Now let's take up the multiple choice question to end part 2 on dot products. Now here is your test question, multiple choice question on dot products. You can pause the video, answer the question, and then look into my solutions. I hope you enjoyed this journey of learning about dot products with the help of few test questions. So the question is straightforward, true or false? A dot j equals to k. What do you think? So when we say I, j, k, so I, j, k are unit vectors along x, y, and z axis, right? So let's understand. This is x, this is y, this is z, and these are the unit vectors I, j, k. Normally we write with this kind of a symbol. So I dot j is what? Since I and j are at right angles, you know, the dot product should be equal to 0, right? So in fact, this is equal to 0, not k, not the unit vector along z. So this statement is false, correct? The next one here is, if v equals to abc, then what is v dot j? Is it b? Well, let's figure it out. J, this vector j could be written as 0, 1, 0, correct? Unit vector along y. So let's find the dot products. So we have ABC dot 0, 1, 0. What you get? So A times 0 is 0 plus B times this is B and 0, which is indeed B. So this one is true. Now we have projection of A on B and projection of A on 3B. So basically we are looking for B as this, and let us say that the vector A is kind of like this. Now projection of A, let's say this is V, right, this is B. So projection of A on B is this much, correct? Vector projection. Now what is the projection of A on 3 times B? 3 times B means this is longer, right? This kind of 3 times. Now it doesn't matter, the projection is still the same, right? It is still the same. So this is true for us. Since we are actually interested in unit vector along B, so magnitude of B doesn't make any difference. Part D is, applying force to a box in exactly the direction you want it to move produces maximum amount of work possible. Well, the answer, as you know, is true, since work done is what? Is the dot product between force and displacement, right? So it is equals to magnitude of force times magnitude of displacement times angle between them. And cos of theta is maximum. What is the value of cos theta? It is between 0 or 1, the absolute value of cos theta, let me write. And it is maximum for theta equals to 0, right? If theta equals to 0, then cos theta equals to 1, which gives you maximum value, right? So it is maximum for theta equals to 0 degrees. That means exactly the direction you want it to move. So with that, I think we conclude this part on dot products. Feel free to share your comments and views. If you share and subscribe, that'd be great. Thanks and all the best.